next topic is geometrical meaning of the zeros of a polynomial. So we'll consider one by one. First of all, consider a linear polynomial. As I've already told you that its geometrical interpretation means when you draw the graph of this polynomial, you will always get a straight line. Its general form is what? Fx is equal to ax plus b. Now, a straight line can intersect the coordinate axis, that is either x-axis or y-axis, in these different forms, right? In the first case, it is touching both the axes. In the second case, it is passing through the origin. Third case, you may find that the line is parallel to x-axis, and in the fourth case, you find that the line is parallel to y-axis, right? So when you solve this linear polynomial, that means when you find the zeros of this polynomial, you will always get a value in terms of x. So we are considering the straight line at that point where it is crossing or intersecting the x-axis. In this case, you may find that the line is intersecting the x-axis or crossing the x-axis at one point. Here also it is intersecting the x-axis, but it is passing through the origin, right? Now here it is parallel to x-axis, means it is not at all touching the x-axis, and here it is parallel to y-axis, that means it is intersecting the x-axis at one point. So where all and at how many points the line is intersecting the x-axis? You may find in the first case 1 point, second case also 1 point, third case of course it is a straight line but it is not touching the x-axis, and in the fourth case it is also touching at 1 point only. So the line where it is crossing the x-axis will give you the zeros of the linear polynomial. So a linear polynomial has at the most one zero, as we have seen that either it has got 1 0, 1 0, no 0 or 1 0. So we can say that at the most it has got 1 0. Now come to the next polynomial, and that is a quadratic polynomial. Its geometrical interpretation is a parabola. Now what is its general form? Fx is equal to ax square plus bx plus c. Now this has got two different forms. What will happen if the coefficient of x square is positive? That means a will be greater than 0. In that case, you will get an upward parabola, and the shape of upward parabola is like this. Why is it called upward parabola? Because it is opening towards the upper side. And if the coefficient of x square is negative, that is a is less than 0, then we call it as a downward parabola, and that is it is opening downwards, right? Now these are the different cases in case of a quadratic polynomial. Now as I've told you, when you solve the quadratic polynomial in x, you will get two different zeros, right? As it has got as the degree of the quadratic polynomial is 2, it has got two zeros. But we see that a parabola is touching the x-axis at 2 points. Here we see that a parabola is touching the x-axis at 1 point, that is at the origin. It may touch the x-axis other than the origin, and it may not touch the x-axis at all. Here these are the cases of downward parabola. The same thing appears here also. This is intersecting or crossing the x-axis at 2 points. Here it is touching at the origin, and here it is not at all touching the x-axis. What does it mean? Here the graph is intersecting at 2 points, means it has got 2 0. Here the graph is touching the x-axis. What does that mean? It means when solve, for example, fx is equal to x square. This is a quadratic polynomial, right? So when you find the zeros, that means fx is equal to 0. That means x square is equal to 0. So what are the values of x? 0 and 0. So you may get coincident points, but the 0 is only 1. That's why it is touching at one point. The same is here also. It may have, for example, here you may see that fx is equal to x square minus 2x minus 1. That is x minus 1 the whole square. So when you equate fx to 0, you may get the value of x as 1 and 1. Again, there are two zeros. It has to have two zeros because it is a quadratic polynomial. So two zeros must be there. Two coincident points are. But in this case, we are getting two coincident points. But when you say that how many zeros, then we say that it is 1 0 because it is just touching the x-axis. It is not at all touching the x-axis. That means it does not contain any 0. Here in case of downward parabola also, you see that it is intersecting at 2 points. It is touching at 1 point and it is not at all touching. So what all cases you are getting? No 0, 1 0, 1 0 or 2 zeros. Therefore, a quadratic polynomial has at the most 2 zeros. Right? So similarly, a cubic polynomial has not got any particular shape of the curve. Therefore, we simply say it as a cubic polynomial. So for a cubic polynomial, there are at the most 3 zeros. What does it mean? It may have no 0, it can have 1 0, 2 zeros or 3 zeros, not more than 3 zeros. So how will you generalize it? In general, a polynomial of degree n has at the most n zeros. Right? So geometrically, the zeros of a polynomial are the x coordinate of the points. These are the points. These are the points. And the x coordinate will be here only on the x-axis, right? So geometrically, the zeros of a polynomial are x coordinate of the points where its graph intersects or touches the x-axis. Okay. Here, each one of the graphs given below is the graph of a polynomial y equal to fx, right? So find the number of zeros of px for each graph. Come to the first question. Here, the graph or the curve is touching not, it is intersecting, it is crossing. The graph or the curve is crossing the x-axis at one point, so it has got 1 0. Here, the curve is intersecting the x-axis at 2 points, so it has got 2 zeros. In the third part, you see, this curve is intersecting the x-axis at 3 different points, so it has got 3 zeros. This straight line is crossing the x-axis at 1 point, so it will have only 1 0. Now, here it is a parabola, so it may have 2 zeros, but both the zeros are coincident one. So when you say that how many zeros are there, we say that only 1 0 is there, right? Now, in this case, it is crossing the x-axis at 4 different points, 1, 2, 3 and 4. So in this figure, in this curve, the number of zeros will be 4 zeros. So here, in this case, you find that a line is parallel to x-axis. That means it will never cross or intersect the x-axis. And in this case, we will not get any 0. So the number of zeros is 0, Z-E-R-O, 0. Now, here, this graph is crossing the x-axis, touching here as well as here. So, how many zeros will be there? 1, 2 and 3. Now, come to the next question. Find the number of zeros between -2 and 2 of the polynomial whose graph is given below. Now, here, a graph is given like this is the shape of the graph, right? Now, you need to find out the zeros between -2 and 2. Here, this is -2 and this is +2. In between these two means interval, the graph is crossing the x-axis at 2 points. So how many zeros you will have? You will have 2 zeros between the point minus 2 and plus 2.